Welcome to Networking Interview Crashcasts, your go-to podcast for acing those tricky networking questions in tech interviews. I'm your host, Sheila, and today we're joined by Victor, a seasoned back-end engineer, to tackle a common interview question. Victor, are you ready to dive in?
Absolutely, Sheila. I'm excited to be here and share some insights.
Great. Let's start with our question for today. Explain the OSI model and its layers. How does it relate to the TCP IP model? Victor, could you begin by giving us a high-level overview of what the OSI model is?
Certainly, Sheila. The OSI model, which stands for Open Systems Interconnection Model, is a conceptual framework used to describe how data communication occurs between devices in a network. It was developed by the International Organization for Standardization in the late 1970s and consists of 7 distinct layers, each with its own specific functions.
That's a great start, Victor. Could you walk us through these 7 layers?
Of course. Starting from the top, we have 1 Application Layer 2, Presentation Layer 3, Session Layer 4, Transport Layer 5, Network Layer 6, Data Link Layer 7, Physical Layer. A helpful mnemonic to remember these layers is all people seem to need data processing.
That's a clever way to remember it. Now let's dig a little deeper. Can you explain the purpose of each layer, starting from the bottom?
Certainly. The physical layer deals with the actual physical connection between devices. It's concerned with things like cables, switches, and the transmission of raw bits. The data link layer is responsible for the reliable transfer of data between 2 directly connected nodes. It handles addressing and error detection. The network layer manages routing and forwarding of data packets between different networks. IP, or Internet Protocol, operates at this layer. The transport layer ensures end-to-end communication and data integrity. TCP, Transmission Control Protocol, and UDP, User Datagram Protocol, are examples of transport layer protocols. The session layer manages sessions or connections between applications. The presentation layer is responsible for data formatting, encryption, and compression. Finally, the application layer is closest to the end user, providing network services directly to applications.
That's a comprehensive explanation, Victor. How does data actually move through these layers?
Great question, Sheila. When data is sent from one device to another, it starts at the application layer of the sending device and moves down through each layer. At each layer, the data is encapsulated with additional information specific to that layer's functions. For example, the transport layer might add a TCP header. Then the network layer adds an IP header, and so on. This process is called encapsulation. When the data reaches the receiving device, it starts at the physical layer and moves up through the layers. Each layer strips off its respective header and passes the data up to the next layer. This process is called de-encapsulation.
That's fascinating, Victor. Now, let's move on to the second part of our question. How does the OSI model relate to the TCP IP model?
The TCP IP model is a simpler 4-layer model that's more commonly used in real-world networking. It consists of 1 Application Layer 2, Transport Layer 3, Internet Layer 4, Network Access Layer. These layers roughly correspond to the OSI model layers. The application layer in TCP IP combines the functions of the application, presentation, and session layers in OSI. The transport layer is the same in both models. The internet layer in TCP IP corresponds to the network layer in OSI. Finally, the network access layer in TCP IP combines the functions of the data link and physical layers in OSI.
That's a great comparison, Victor. Now let's consider some edge cases. How would you explain the relevance of the OSI model in today's networking landscape, given that TCP IP is more commonly used?
That's an insightful question, Sheila. While it's true that TCP IP is more prevalent in practical networking, the OSI model still holds significant value. It provides a more detailed, standardized way to understand and troubleshoot network issues. For instance, when diagnosing a network problem, the OSI model helps engineers pinpoint which layer the issue is occurring in. Is it a physical connection problem, physical layer, a routing issue, network layer, or an application-specific problem? Application layer. Moreover, some modern technologies align more closely with the OSI model. For example, the Session Initiation Protocol, SEP, used in VoIP communications. That's Voice over Internet Protocol, or phone calls over the Internet, corresponds well with the session layer of the OSI model.
Excellent point, Victor. As we wrap up, what advice would you give to someone preparing to answer this question in an interview?
I'd recommend a few key points. 1. Start with a high-level overview before diving into details. 2. Be prepared to explain each layer's function and give examples of protocols or technologies associated with each. 3. Understand how data flows through the layers and be able to explain encapsulation and de-encapsulation. 4. Know the differences and similarities between the OSI and TCP IP models. 5. Be ready to discuss real-world applications and relevance of the models in modern networking. Lastly, don't just memorize the layers. Try to understand the logic behind the layered approach and why it's useful in networking.
That's excellent advice, Victor. Thank you for sharing your expertise with us today. To our listeners, remember that understanding these foundational concepts is crucial for any senior back-end engineer role. Practice explaining these models clearly and concisely, and you'll be well prepared for your next networking interview. That's all for today's episode of Networking Interview Crashcasts. Join us next time for more in-depth discussions on crucial networking concepts. Until then, happy studying. Happy.